So in this session, we are going to understand what is meant by queue. So in the previous session, we have understood in detail about stacks. Now just the opposite or a just slight modification for the stack is known as queue. So queue have many uses for booking a ticket, or if you're in your airports or somewhere, if you see in movie theaters, you can see a queues where the people stand in a queue and they will collect the ticket and come out first. Means whoever go first, they will come first outside. So that is known as the queue. So that is only written over here, the first in first out principle. And the stack is the pile of books, if you can observe as the example. For the queue, you can take an example like standing in a line like that. Okay, so that is the first in first out principle. You can see we have two pointers known as front pointer and rear pointer, and we can have two operations here, that is NQ and here NQ and DQ. So basically these pointers are very important because as we are taking the inputs from the back, from the back, so to reduce the complexity we are going to have the rear option. So with the help of this rear, we can simply append the elements that are coming in faster, and we can simply DQ them, means we can simply pop in the terms of stack. I can say we can simply pop. So that is known as the DQ, but we are doing with the help of the front variable. Okay, so this is the simple diagram. Also you can see over here we are enqueuing from the back and we are dequeuing from the front. So these are the simple two terms, and you can also take the other two terms also, front, rear, NQ, DQ. So these are the four terms, important terms in the queue that you need to remember always. So if you see further, these are the stuff. We also already know what is meant by NQ. Adding a new element in the 10, that will be from the rear end, not from the front end. So if you want to DQ that, you are going to do from the front end. So as like we have seen in the stack, the queue also can be implemented with the both array as well as the linked list. So if you see the first in first out for the stack, and the first in first out for the stack, that is for the queue, and last in first out for the stack, the same thing written here also. So if you see in the Java inbuilt options, we have the offer and pull. So here we need to understand very important concept. In the stack, that is push and pop for insertion and deletion, but in the queue it is somewhat the terms are opposite. So, the terms that we need to by heart by ourselves, we can't do anything. So the first implementation that we are going to see with the help of the inbuilt Java classes, that is the offer. Offer means insertion and element. So the next one is poll. Poll means to remove from front, remove front element. Okay, peek means view from front element, and is empty means check whether the queue is empty or not. And finally is queue is the queue size means the number of elements that we are going to. So in my VS Code, just I am trying to demonstrate with the help of the array. So this is basically with the help of the dynamic array. If you are using see this line, what is this line meant by that? So first of all, I will be going to show how to use the queues with the help of the inbuilt classes by Java. So we are creating an object called queue. So with the help of this object queue, here you can see we are creating new linked list, and we are also introducing the type safety of integer. So here we are performing the NQ, that is known as with the offer. Already we have seen what is meant by offer. So offer here means to insert an element or to push an element, let's say. So in the stack, if you in the terminology of stack, I can simply say to push an element into the queue, that is here known as offer. So you are pushing 10, 20, 30 with the help of this object queue dot offer. You are pushing all the three. So after that, you are going to push like after pushing all this stuff, you are going to see what is at the top. The top element is that 10, because this is the queue. The front element is known as the top element. After that, the poll means you are going to remove the topmost element. You are going to DQ that. So this is known as the DQ. So the 10 will be removed. Why 10 will be removed? Because here it's as a queue, the topmost element, the front element will be removed from the queue. So finally we are displaying all the elements. It will be printing 20 and 30. So if I compile and run, you can understand very clearly. So it is saying front 10 from this line, because it's seeing what is the front element. So it is saying removed 10 because that element 10 is in the front element. Okay, it is removing very clearly. So finally we are seeing what is the elements are present inside the queue. So it is saying 20 and 30. Now you can see clearly 20 is in the front and 30 is in the rear end. The front is pointing 20 and the rear is pointing 30. Again, if you perform the poll operation, let's see what happens. So I already performed the poll, but I am again performing the poll. So let's see what happens if I compile and run. So you can see it is saying remove 10 and remove 20, and it is showing one element in 30. Okay, that front, rear, and that all things will be pointing now only for this 30 only now, because the front rear are combined and pointing to 30. Okay, as why it is 20 removed first, because this is the q, the first element will be removed as this comes first. So we already know q is the first in first out philosophy, it follows. Now we will also understand, we will not use the inbuilt packages. Okay, I am going to remove this stuff here. So I am going to remove this printing. So okay, let it the printings be there. So it is showing error. So if you hover over that, you can see quick fix. So if you hover that, you can see create class q in demo. No, I don't want that. Create a q in package. So just click that. So basically it will be going to create a file, another file for you. Inside that file, it is also accepting the type safety. Here inside that we are going to have all the stuff. So again it is showing error because we are not having any functions called offer and peak and poll. So inside this queue, what I will be going to do is now, so in the demo I will be introducing one by one stuff. So I will be going to remove all the stuff from here. So this linked list is also not there. So we can also typecast this to queue type. Okay, now it's very perfect. So we are creating an object of queue that we have created in this. So we can make this class as public so that we can use in that class, in this demo class. Okay, so in this queue class, what I will be going to do is I will be going to implement with the help of the array. So for that purpose, I am going to have the variables front and also, or front rear. So I am going to have that variables. So this is the integer array. Okay, we are storing all the elements in this integer. So currently it is empty now. Okay, so after that we have a variable called front and we have a variable called rear. We have already seen in the PPT, and we have a variable called size. So we have a constructor. So public q. So what inside this we are going to initialize the size 5. Okay, so that's your wish, you can initialize the size according to your requirement, and we are going to initialize the size here. Okay, so basically this integer array will be of size 5. After that we are going to assign front value as 0 and rear value as -1. Okay, so after that I am just performing the enq operation. In the enq operation you can see we have the enq. So you can also change name as to offer, but as for our understanding what we understood, so that putting element is enq, removing element is deq. So it's not inbuilt given by Java. We can modify our names, we can modify our function names. So that's for understanding purpose I named it as enq, not rather than offer. Okay, so after that what I will be going to do is I will be going to check whether the rear or whether the last pointer is the size -1. If that's the case, we are printing stack or queue or floor. So then we are returning 0. If the rear is equals to size, if that's false, then we can simply say that array plus data, and we can simply print that data has been inserted. We can say the data has been inserted in this array. So let's quickly come to the demo, and inside this demo I will be going to say with the help of this queue. So say q dot enq. So inside this enq we are going to pass data as 50. That's your wish. So inside this queue also you can see we have a function called enq. We're accepting an integer called data. Now if I compile and run, if I again come to demo, if I again pass and the 2-3 variables. Okay, if I say this as 25 and if I say this as 99 or 92 or something, if I again compile and run, see it is saying 50 is inserted, 25 is inserted, 92 is inserted. So basically we are successfully created a function called enq which can insert all the stuff into the array with this array arr. Now we are able to make this enq. Now we will make deq, peak, and the other functions as well, so that you can understand how we can inbuild the queue. So now if you observe, I have made 2 functions. One is called deq and another is called peak. So in the deq, basically this will remove whatever the element that you means whatever the element is at the front, that we have understood from the slides also. Now inside this deq function you are checking that whether front is greater than rear. If that's the case, you can simply say under flow and return -1. So after that you can just return the array of front plus. So this will be going to remove the frontmost element, and it will be going to return what the element that has been removed. Okay, so the same stuff as the stack only. In this peak value you can simply return the value at the front. So here inside if statement I simply have a checking thing. So I will simply come to the demo file. Inside this demo file we have just enqueued now. So I will also show how you can do deq. So for that I will say system.print. Inside that I will say dequeued element. So after that I will be going to append with the nums.deq. That's it. Here, not nums here. In the stack we have used. So here the object is q. You can say q.deq. Now if I compile and run, So you can see we have inserted 3 elements and we have dequeued element 50 because it is at the front and this 92 is at the rear. Now if you want to see, wait, system.error not system.out, that is, okay, there is no issue in that. And if I copy this statement and if I say peak, because we already make the value for the peak, so you can simply remove this dequeue from the here and you can say peak here. You can call peak function with the help of object q. You can compile and run. If you see, we have 50, 25, 92 inserted to the array and we have dequeued 50 and we have seen what is at the top. After removing the top front element, now 25 is at the front, so 25 is saying it is at the front. So we understood what is enqueue, to enqueue the element, what is dequeue, to remove the element at the front, and finally peak to see what is element at the front. And finally we can also display all the elements what are there in the queue. So you can see clearly with the help of this display queue function, we can simply see, show queue function. Check, just this is a normal check whether this front is greater than rear, only we are going to start our work, otherwise we don't start work. So you can see this kind of checking is there in the peak, this peak as well, and this kind of checking is there in the dequeue and in the enqueue also. So checkings must be there, otherwise it will be going to throw you errors or exceptions in Java. Okay, that is array outbound, array inbound, or array underflow, stack overflow. That kind of errors will be shown to you. So that's the reason you are going to have these kind of checkings. After that checking, so you are going to run a for loop. Inside that you are going to print all the stuff what is there inside this array. So quickly I will come to the demo, and after this picking and dequeuing, I will be going to call with the help of this object. So I will be going to call show queue. That's it. If you compile and run, we have 25 and 92 elements in the queue because we have already dequeued the element here. Okay, 50 is removed and we are having only 25, 92. Those are printed in the terminal. So I hope you understood how the queue is implemented with the help of the array. The array here that we have declared here is the array. So I hope this makes some sense. So enqueue this is dequeue. Finally we have peak and show queue, and that's the functions.